Look up. That endless blue above us, we see it every day. But how often do we ask, why is the sky blue? It may seem like a simple question, yet behind that color is a story of physics, chemistry, and the very evolution of Earth itself. Let's take a closer look. Sunlight, though it appears white, is actually a blend of all the colors we see in a rainbow. Red, orange, yellow, green, blue, indigo, violet, each with a different wavelength. Red has long, low-energy waves. Blue and violet, on the other hand, travel in much shorter, more energetic waves. As sunlight enters Earth's atmosphere, it collides with tiny air molecules, mostly nitrogen and oxygen. These molecules are especially effective at scattering shorter wavelengths like blue. This scattering process, known as Rayleigh scattering, redirects blue light in all directions, far more than red. That's why when we look up during the day, we see the sky glowing blue. But wait, violet light scatters even more. So why isn't the sky purple? There are two reasons. First, the sun emits less violet than blue. And second, the human eye is less sensitive to violet light. Our eyes respond more strongly to blue wavelengths, so blue becomes the dominant color we perceive. Now let's look at sunrise and sunset. At these times, the sun is low on the horizon. Its light must pass through a thicker slice of the atmosphere. Much of the blue light gets scattered out of view, leaving the longer red and orange wavelengths to reach our eyes. That's why dawn and dusk bring such vivid, fiery skies. But what about other planets? On Mars, the sky is a dusty orange during the day, but turns blue at sunset. The moon, with no atmosphere, offers a pitch-black sky, even in daylight. Venus has a pale, yellowish-white sky, heavy with thick clouds of sulfuric acid. And Titan, Saturn's largest moon, glows in a perpetual orange haze, cloaked in hydrocarbons. Every sky tells a different story, depending on its atmosphere. Even on Earth, altitude affects what we see. At higher elevations, there's less atmosphere to scatter light, so the sky appears darker and deeper blue. This is especially noticeable from mountaintops or from space. Astronauts aboard the International Space Station witness a black sky just beyond the thin blue curve of our planet. Here's something surprising. The sky wasn't always blue. Billions of years ago, Earth's atmosphere was filled with methane, carbon dioxide, and volcanic gases. Back then, without oxygen, the sky likely had a hazy orange appearance. Then came cyanobacteria, tiny organisms that began releasing oxygen through photosynthesis. Over millions of years, this oxygen reshaped the atmosphere, and eventually, the sky turned blue.
But the story doesn't stop there. Today, pollution plays a major role in how the sky looks. Larger particles, from smog, dust, or wildfires, scatter light in a different way. This process, called me-scattering, makes the sky look hazy, pale, or even gray. In severe weather, the sky can even turn a greenish hue, often signaling an approaching storm. And no, the ocean isn't blue because it reflects the sky. It's a common misconception. In reality, water absorbs longer wavelengths, like red and orange, and reflects the shorter blue ones back to our eyes. That's why oceans appear blue, even under overcast skies. So why is the sky blue? Because of the way sunlight interacts with air molecules. Because of the size of those molecules. Because of how our eyes interpret scattered light. But it's also because Earth's atmosphere and life itself changed over billions of years. What we see now is a canvas painted by light, air, and time. The next time you look up at the sky, remember, you're witnessing a daily phenomenon shaped by physics and ancient history. And somewhere, far away, on another planet, someone else might be wondering why their sky isn't blue.